Hi, guys, and welcome to this one of at least 4 recordings related to the retrograde motion of Mars. Basically, the project itself is divided at least into 3 separate sections that you need to be aware of, okay? There is the first part, which is really based on data. So you're going to take those data and represent it on a graph related to Mars itself. What you're given in that part are different times of the year and the location of the planet based on the coordinates that was given to you, okay? So you take that data and you represent it on the graph. You're presented on a graph that depicts the sky with the background stars in the sky as indicated on the graph itself. So as the day changes, you're going to see the planet move from location to location to location to location, and then you will see the retrograde that at some point is going to return back, and sometimes it's going to continue in the same direction as everybody else, okay? So based on that graph, you're going to answer questions. When does the planet start its retrograde motion, and when is it going to resume? So this is the first part. The second part deals with 2 models for explaining this data. So the first one is actually hard observations. This is what you will see if you were to go every 10 days or so, you note the position of the planet in the sky. That is evidence. This is data. This is observation. No two will disagree on it. Everybody agrees on that. The second part, though, of the project is coming up with a theory to explain this retrograde motion. There are 2 models, as I was saying. The first one is where the sun is the center of the solar system, namely Mars and Earth are both going around the sun. So in that scenario, we will try to explain the retrograde motion based on this model. The other model is that the Earth is actually sitting still and Mars is revolving around the Earth, okay? We will try, but Mars is actually not going in a circle around the Earth. It's going to go on a tiny circle around the big circle around the Earth. So based on that model, which is called the geocentric model, as opposed to the first model, which is the heliocentric model. So in the geocentric model, we again try to explain the retrograde motion. Once we come up with that, that is basically 2 different models. Then the third part of the project is you take the heliocentric model, which is the correct model that we have, and you try to make predictions, not just for Mars, but for a lot of other objects in the solar system, namely Venus, Jupiter, Saturn, Ceres. So there are so many objects that you're going to predict their next retrograde motion. So you're going to be given data, okay, when did the last time that we know it happened? And you take that, you use mathematical formulas, and I will show you how that works. And you make predictions on the future, when is that going to happen? So this is the power of a good scientific theory. Good scientific theory makes predictions. So let me delve into the project itself and share with you the screen. So if you come to the assignment, this is how it looks like. You have 2 links. You have the link that takes you to the instructions in detail, and you have a link for a PDF fillable file. So that's, you can use that to answer your questions. Now, if that doesn't work with you, you can always print it and fill it by hand if you don't know how to fill it manually, or you can make your own. So if there is difficulty with the PDF, you can always use that. Now, please note the rubric on the bottom. This is how you're going to be graded for this assignment. As you can clearly see, there are a lot of components in it. So please make sure you go through the rubric and make checks as you go along. So there are graphs to be graphed and so many things to be done. So let me click on this link, because at this point of the game, this is the most important link. It takes me to the instructions. So I clicked on it. So this is, it tells me, as I was saying, we're going to talk today only about the first part, the date and the location of the planet. It gives me two values for it. It gives me the right ascension, which is, if you wish, east-west location, and the declination, which is north-south location in the sky, of course. So those are the coordinates. On July 10, 2005, I have this right ascension, 1 hour and 13 minutes. And the declination is 4 degrees and 54 minutes, arc minutes, that is, okay? So I have these two locations. I should be able to plot this date. And I go along in here in the bottom, as you can clearly see, it's every 10 days or so this repeats, okay? Until I come to this side and here again. So I have this date, which is November 20th, 2005, I'm sorry. And I keep on moving until I reach March 20th, 2006. So imagine the data coming from almost a year, I mean, slightly more than half a year anyway, of data from July till March of the next year, okay? And these are all the values that I am given. So if I look at this graph in here, the dark dots that you see in here, 1, 2, 3, below the ecliptic, 1, 2, 3, 4 above the ecliptic, those are background stars. Those serve as a reference for you, okay? So now I need to locate the planet on Mars, that is, on July 10th, 2005. Well, it's 1 hour and 13 minutes. You can clearly see in here 1 hour, 2 hours, 3 hours, 4 hours, and 5 hours, and so on and so forth on the graph. And it's also on the declination 4 degrees and 54 arc minutes. This is 0 degrees, this is 5 degrees. So it must be just below this one, okay? And then 10 degrees, 15 degrees, 20 degrees, and 25 degrees. All of the data in here are between degrees, between 4 degrees, and then starts to increase, 16 degrees, and then starts to decrease again, 15 degrees, 16, 17, 18, up to 24 degrees. So that's all I need. From 0 to 25 should cover all of my declination locations. And again, the hours are from 1 hour and 13 minutes, and then it's going to start to increase. Then it decreases back to 2 hours. Then it's 2 hours and 34 minutes until 4 hours and 55 minutes. 4 hours and 55 arc minutes should put it right around this side, okay? So this is basically the entire graph is covered in here. Now, let's try to find it on this date, as I would say, on July 10th, 2005. It's 1 hour and 13 minutes, okay. This is 1 hour, this is 2 hours. Remember, there are 60 arc minutes in an hour. So going from 1 hour to 2 hours, that's 60 arc minutes. How many divisions in here? I have 1, 2, 3, 4, 5, and 6. So each one of them represents 10 minutes. But I don't have 1 hour and 10 minutes, I have 1 hour and 13 minutes. So this is 1 hour, this is 10 minutes. 1 hour and 10 minutes plus halfway, that's 1 hour, basically 15 minutes. But this is slightly the halfway, just below halfway. So this is 1 hour and 13 minutes. Add to it, if I look at the data, 4 degrees and 54 arc seconds. 4 degrees and 54 arc minutes. 54 arc minutes is almost a degree because 60 arc minutes is a degree. So this is almost 5 degrees. So just 5 degree dash below it. So this is 5 degrees. So we're just below that. This is 1 hour and 10 minutes. This is hour and 15 minutes. And this is an hour and 13 minutes. Since we're just below that, this is the place where the planet is. So I need to mark a circle in there, okay? Just as to illustrate the point, and here I'm going to take another date, which is the next one. On July 20th, 2005, it's 1 hour and 37 minutes. So it's moved toward the 2 hours. And then it's 7 degrees and 9 arc minutes. So it's above the 7 degrees, slightly more than that. Okay, so let's try to do that again. So it's 1 hour and 37 minutes. So this is 1 hour and 10 minutes, 1 hour and 20 minutes, 1 hour and 30 minutes, 30 arc minutes. 1 hour and 30 arc, 1 hour and 30 minutes, then in this case, it uses the hours exactly in the minutes on this side. 37 minutes is almost 40 minutes, but below it. So this is where it's supposed to be. On the other side, it's 7 degrees. So it's 5, 6, 7 degrees in 9 arc minutes, okay? So in this case, it's slightly above that. With the divisions in here, from here to here, you can, unless you use a millimetric ruler to find the exact location divided by all of the divisions in here, 60 arc minutes make a degree, then you can find where almost the 10 arc minutes is. Otherwise, just take it very close from the 7 minutes. 7 degrees. So you have the 7 degrees and 1 hour and 37 minutes. So initially it was somewhere in here. Now it has moved to here, 10 days later. And you're going to follow the path, and it should be not too far from the ecliptic. At some point, as I was saying, is going to move forward, okay? So this is the first part. Based on that, you're going to answer the questions in here. What is the ecliptic? And if you're not sure about it, that's basically the path of the apparent path of the sun in the night sky, which is a projection of the actual path of the Earth on the in the sky. What does the orbit of Mars? Why does the orbit of Mars stay close to the ecliptic? It's because basically you can read more about it. It's how the solar system formed, and you can explain basically how the ecliptic formed because of the conservation of angular momentum and everybody flattened. So that's more or less why is that. So you're going to see it not too far from the ecliptic, actually. It's going to move along this path in here. Anyway, what are the meanings of the term retrograde and prograde? So at some point, it's going to be moving in the same direction. That's what your prograde motion. Retrograde is moving backward, and then it's going to prograde again, okay? What about date did Mars begin its retrograde motion? And about what date did Mars return to prograde motion? So at some point, you're going to see somewhere in here that it's going to start to move backward. That is the date you're going to read. Is it this date? Is this date? You're going to find the date exactly when that is going to happen. And it's going to be moving backward, and then it's going to resume its prograde motion. So let's say, for example, this is the date. You're going to look in the graph and say, I don't know, say, for example, January 1st. I don't know. Just you have to follow what the graph tells you. So you really need to plot the graph first to answer these questions. Okay, so this is the first part. So let me share with you another screen in here. Let me stop sharing that. And let me share with you another screen to show you how you're going to fill this information. What is the share button? So again, don't forget to include your name. This is a project, so you're strongly urged to work in teams. So when you're working with teams, you have to include the other people's names in your name with your name also. Also, don't forget the objective. Don't start with the objectives yet, okay? Usually it's a good idea to leave them toward the end, and then the goal of this activity, hopefully after you complete it, you understand what you're doing. So at this point in here, so you're going to basically, I already stated what these parts are, so you can always try to do that on your own in here. Try to understand what's going on and then explain it. So where is I really don't know how to work this software very much, so I'm going to try to see if I can get, where is the taking notes in here? More tools. Oh man, there's so many ridiculous tools. Comments. Oh no, I don't know. Anyway, here is the point in here. Oh, I see some more tools that popped up in here. So let's see here if that's going to work. Okay, so on this date, 1 hour and 13 minutes combined with 5. So there is a dot in here. So I'm going to try to plot a dot in here. Obviously, more than a dot, because let's see here if I can make it. If I can zoom. What is the zoom feature in here? Sorry about that. Okay, so that's better. So this is basically the let me delete that button again. So let's again try to draw it. Okay, so we have 1 hour, 10 minutes, 13 minutes is somewhere in here. So I have a dot in here. I'm going to just copy it and I'm going to paste it. I cannot copy this. Okay, anyway, so let's make another one in here, which is 1 hour and 20 minutes, 1 hour and 30 minutes, 1 hour and 37 minutes, and it's about 7. So it has moved forward on the next date. Let me just to see if I can find the third date in here. On August 1st, 2005, I have the location as 2 hours and 4 minutes. So it's 2 hours and 4 minutes. So this is 2 hours. And this is 5 minutes midway. So it's somewhere less than midway. And the location on it's 9 degrees and 36 minutes. So it's 9 degrees and a half, basically, slightly more than half. So this is 9 degrees, because remember this is 10. So this is 9 degrees and a half. So it's going to be in here. And it's 1 hour, 2 hours and 4 minutes. So it's very close, really, from the midway. So this is, again, the 3 points. So now I am ready to connect these 3 points. Okay. You don't need to do that until after you're done with the project. Then that is when you connect your points. So don't start connecting your points until you complete the task, until you find all of the points in here, probably here, and then you connect them. At that point, you say, this is the path of the planet, okay? So we're going to look into this point in here and say, this is the date when it started into retrograde, and this is the date when it resumed its prograde. And again, answer the questions that are related to this topic in here. If you guys have difficulty, please do not hesitate to reach out to me for any part of this assignment. And as I was saying, I will follow up with more videos. Thank you.